Hello everyone, welcome to my class. In this video I'll be talking about describing motion. These are our objectives. Well, when we talk about this topic, we can start with these two questions. Why and how? Why describing motion and how to describe motion? Why? So it won't depend on observer, because when we describe motion in daily life, we talk about the motion according to our perspective. Yeah. So for the more scientific method, or for doing calculations, for doing research, we need to use some proper way to describe motion. So for instance, let's see this diagram. We have a child running in a field here, and there are three people. According to me, the child is moving from right to left. Yeah. According to this person, the child is running away from him. According to this person, the child is crossing him. According to this person, the child is running toward him or her. So as you can see, the motion depends on all these observers. Yeah. So in science, in physics, we should use some reference for the motion, so we can use it for precise measurements. So how? There are several ways to describe motion. So according to the position of object, so object is moving from A position to the B position, B point to A point, something like this. Or very basic way to describe the motion is the distance. So the object is moving this much distance, for example, from A point to B point, the object has moved 10 meters. So to improve this description, we can add up time. So the object is moving 10 meters from A to B point in 5 seconds. So you can see we have improved the description of the motion. We can also describe by speed, yeah, how fast the object is moving. To talk about how fast the object is moving, we need to combine distance and time here. So we can improve the description even more. So velocity is even more advanced way. We need to state the direction of the moving object. Yeah. So when we talk about the object's speed, the object is moving this much, but if we add a direction, so object is moving from south to north or east to west, that means we are describing the motion by velocity. Acceleration even advanced. In acceleration, we are talking about changing velocity in every second or every time. So how fast the object is moving and how it's changing. Is it speeding up or slowing down? So this is more advanced way. And displaying on graph, another method to describe motion is displaying the motion on graph. Instead of explaining, if we display the motion on graph, which will be easier to understand about the motion. Yeah. So in this video, I'll be talking about speed, velocity, and acceleration. In my next video, I will explain about displaying motion on graph and graph types. Well, average speed is equal to distance moved over time taken. So what is speed, first of all? Speed means distance traveled in a given time, or speed means how fast is something moving, or speed means how much time taken to travel this much distance. All relates to the speed. Yeah. So when we go from one place to another place, we sometimes stop, sometimes we speed up, sometimes we slow down. So we talk about average speed here. So we are not driving car, or we are not walking uniformly. We are changing our speed throughout the journey. So therefore, we talk about average speed here. Average speed is calculated as total distance over total time. According to SI units, distance measured in meters, time measured in seconds. So the SI unit of speed becomes meter per second. For example, car travels 50 meters in 2 seconds. Accordingly, we can calculate the speed. Yeah, speed is equal to distance over time. Distance is 50, time is 2 seconds. So the result is 25 meter per second. Meter per second could be written in this way as well. Meter second negative 1 power. So if that is speed, yeah, speed is distance traveled in time. So what is velocity? So let's talk about velocity here. Velocity is speed in a given direction. So when we talk about how fast something is moving, we are talking about the speed. But if we say the boat is moving this much speed to this direction, then it is velocity. So we have a boat here, you can see it's moving fast, but how much fast? Velocity is 25 meter per second due west. So you can see direction is added here. So because of direction is added, we call it, this is the velocity. Yeah, 25 meter per second due west. So speed plus direction is velocity. Example, the bicycle is moving from left to right. And so we already stated that it is from left to right. So it is velocity. Yeah, 10 meter per second to the right. It's moving from left to right. Therefore, it is positive velocity. And if we want to say velocity to the left is negative because the bicycle is moving from left to right. So velocity according to left is negative. Yeah. So negative 10 meter per second to the left. Another way to say about the velocity of this cyclist. What is your vector vector? There is this is from a movie. Yeah. So in here we can talk about two types of quantities. We have vector quantities and scalar quantities. Scalar quantities, we just state the quantity itself. But in vector quantities, quantity plus direction. So if we say direction as well, it is vector quantities. Or if quantities has direction, it is already vector quantity. So far, we just talked about speed and velocity. Yes? Speed has no direction, so we call it is scalar quantity. Velocity has direction, so it is vector quantity. Quantities such as velocity are called vector quantities because they have size and direction. So if quantity has size and direction, it is vector quantity. Acceleration is the rate at which an object increases speed or velocity. So what is acceleration? Acceleration is speeding up or change in speed or velocity. Or when objects increase their speed or velocity, we call it the object is accelerating. Acceleration equation here, acceleration is equal to change in velocity over time taken. Change in velocity, how we get it? We get from final velocity minus initial velocity. So V here stands for final velocity and U stands for initial velocity over time taken during this period. And A stands for acceleration. Velocity measured in meter per second. You remember from the previous slides. Time measured in second. So acceleration unit we can get from here meter per second over second. Yeah, because change in velocity over time taken is equal to acceleration. So velocity unit is meter per second and second for time. So acceleration unit we can say meter per second or meter per second square. Well, we have an example for acceleration here. A drag car increases its velocity from 0 to 60 meter per second in 3 seconds. So acceleration is equal to final velocity minus initial velocity over time. What is final velocity here? Velocity increase from 0 to 60 meter per second. So 60 meter per second is the final velocity, initial is 0, and time taken for this period is 3 seconds. So from here, acceleration is equal to 60 minus 0 over 3, and acceleration will be 20 meter per second squared. So don't forget, acceleration is vector quantity because it has size and direction. Yeah, size and direction, then it is vector quantity. Deceleration, it's negative acceleration. Deceleration means negative acceleration or slowing down. Deceleration is negative acceleration. The object is slowing down. And when we write deceleration, we write with negative. Yeah. Example, negative 4 meter per second squared. Constant acceleration example. What is constant acceleration? Constant acceleration means when acceleration uniformly changing. For example, in every second, if acceleration increases 10 meter per second, 10 meter per second, 10 meter per second, and it's called constant acceleration. So we have an example here. A car passes point A with a velocity of 10 meter per second. It has a steady constant acceleration of 4 meter per second squared. What is the velocity when it passes point B? So every second, car is increasing its acceleration 4 meter per second. So for 6 seconds, how much acceleration will be changing? So 6 times 4 will be 24 meter per second. The solution is car gains 4 meter per second of velocity every second. So in 6 seconds, it gains an extra 24 meter per second. Yeah, final velocity is equal to initial velocity plus extra velocity, which will be 10 meter per second plus 24 meter per second will be 34 meter per second. All right, this is for this video. Thanks for watching. I'll see you in my next videos.